Hello and welcome back to Educator.com and welcome back to Physical Chemistry. So today we're going to start off with our example problems for this particular entropy section. So we've done a lot of discussion about entropy, a lot of mathematical derivations, and now we just want to become familiar with doing problems. That's it. So we are going to do a lot of them, just like we did for energy. Let's go ahead and get started. So again, before I jump into the problems, I want to do the same thing that I did with energy, which was stop and take a look at what it is that we want to bring to the table as far as our tools. What do we need to know? And I discussed a little bit of that in the last few lessons, especially when we did a summary of entropy, but I'd like to do it again just so we have at least a list of equations that we want to refer to immediately instead of pouring through a whole bunch of derivations and things. So what do we need to know in order to solve entropy problems? Well, one of the things that you need to know is the fundamental equation of thermodynamics. So in general, the fundamental equation of thermodynamics is not necessarily going to be used for problem solving, but it's a nice thing to be able to know. So, the fundamental equation of thermodynamics. So that is ds is equal to 1 over t du plus p over t dv. That's it. Fundamental equation of thermodynamics. It's derived from the first and second laws. So, first law being du equals dq minus dw, and the second law, which is the definition of entropy, ds equals dq reversible over t. So, definitely that equation you want to know. Okay. Now, for entropy, as a function of temperature and volume, this is what you want to know. You want to know the total differential expression, which is always easily derived. You just take the derivative. So it's going to be ds over dt, constant v, dt, plus ds dv under constant t, dv. There we go. And the actual equation that you want to bring to the table is ds equals cv over t dt plus alpha over k dv. This is the equation that you want to know. Just like for energy. Absolutely, you have to know this. Most problems begin with this equation or the next one that I'm going to write. Now, in the case of dealing with entropy, where entropy is going to be a function of temperature and pressure, so if pressure is mentioned in the problem, we have ds is equal to, well, ds dt under constant pressure, dt, excuse me, plus, let's see, ds dp under constant temperature, dp. And of course, the actual derivation that we did was the following. ds equals cp over t dt, excuse me, minus volume times the coefficient of thermal expansion times dp. So this is the equation. This is the other one that you want to bring to the table. That's it. And of course, alpha and k, we definitely want to know those definitions. So alpha, that was equal to 1 over v times dv dt under constant pressure. And kappa, which is the coefficient of compressibility, is minus 1 over v, and it's the rate of change of volume. It's the change in volume per unit change in pressure under conditions of constant temperature. That's it. So these two, again, these are sort of some of the things that we want to bring to